In this video, we're going to go through some examples that involve trig identities. Let's have a look at what is included in the formula booklet. In section 3.5, you're told that tan theta is equal to sine theta over cos theta. In section 3.6, you're given various identities. Cos squared plus sine squared equals 1, which can be rearranged to give you cos squared theta equals 1 minus sine squared theta, or sine squared theta equals 1 minus cos squared theta. They are often useful. You're told that sine 2 theta is equal to 2 sine theta cos theta, and you're given three identities for cos 2 theta, which is equal to cos squared theta minus sine squared theta, or 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. We'll be using all of those, or at least some of them. Example 1. If cos theta equals minus 1, and theta is in the range pi over 2 and pi, that means theta lies between pi over 2 and pi radians. So if we draw our cast diagram, we will get this. So CAST, and we're told that cos theta is minus a half, and it is in the range pi over 2 and pi, which means we are in the second quadrant. So we need to take that into account when answering the questions. So we are told that cos theta equals minus 1. Well, we can use cos squared theta plus sine squared theta equals 1. So cos squared theta plus sine squared theta equals 1. Therefore, minus a half plus sine squared theta equals 1. Well, minus a half squared, sorry. So minus a half squared is a quarter, plus sine squared theta equals 1. So sine squared theta equals 3 over 4. So sine theta equals root 3 over root 4, which is root 3 over 2, and it's positive or negative. But now we use our range of values. We want it to be in quadrant 2, so sine theta must be positive in that quadrant, so sine theta is equal to root 3 over 2. Part B, tan theta. Well, we know that tan theta is equal to sine theta over cos theta. Well, we know that sine theta is root 3 over 2, so tan theta equals root 3 over 2 all over cos theta, which is minus a half. So that means that tan theta is equal to root 3 over 2 times minus 2 over 1. Well, they cancel. So tan theta is equal to minus root 3. And just checking back to your diagram, we know that tan in quadrant 2 is negative, so that will be correct. Part C, find sine 2 theta. Well, we know that sine 2 theta is equal to 2 sine theta cos theta. So sine 2 theta is equal to 2 times root 3 over 2 times minus a half. So sine 2 theta, well, the 2's there cancel. So you are given that sine 2 theta is equal to minus root 3 over 2. Now, does that answer make sense? Well, let's go back to our cast diagram. So CAST. We know that sine theta is in here, and we know that it is positive. So sine 2 theta is going to be either in quadrant 3 or quadrant 4, and in there sine is negative. So that does make sense. D, find cos 2 theta. Well, I've actually got 3 different identities for cos 2 theta. I've got cos squared theta minus sine squared theta, or 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. And seeing as I've got both sine theta and cos theta, I can use either. So I'm actually going to use the middle one. So cos 2 theta is equal to 2 cos squared theta minus 1. So cos 2 theta is equal to 2 times minus a half squared minus 1. Well, minus a half squared is a quarter, times 2 is a half, minus 1. So cos 2 theta is equal to minus a half. Question 2. Find the exact value of 3 sine squared 5x plus 3 cos squared 5x. Well, if you look at what we're given in the formula booklet, we've got nothing that looks like sine squared 5x plus cos squared 5x. But I'm going to show you a trick. We have the identity cos squared theta plus sine squared theta is equal to 1. If you look at that identity, theta could be any value. It could be 30 degrees, it could be 60 degrees, it could be 935 degrees, it could be A degrees, it could be 5x degrees. The only thing that is important is that they are identical. So we can write this. We can write 3 sine squared 5x plus 3 cos squared 5x. We can factorize out the 3, so we get 3 sine squared 5x plus cos squared 5x. And we know that sine squared 5x plus cos squared 5x is equal to 1. So we've got 3 times 1. Therefore, 3 sine squared 5x plus 3 cos squared 5x is equal to 3. Question 3. Show that sine 15 degrees is equal to the square root of 2 minus root 3 all over 4. Again, our exact angles we know are 30, 45, 60 degrees. We don't have an exact value for any angle of 15 degrees. But if you look at my double identities, I've got a double angle. The double angle for sine is equal to 2 sine theta cos theta, but I don't know cos theta, so that's not really much use to me. But I do have cos 2 theta is equal to 1 minus 2 sine squared theta. And looking at the question, the square root of 2 minus root 3 over 4, I'm probably going to need a square root, so that has got sine in it. And if I look very carefully, 2 times 15 degrees is equal to 30 degrees. So I'm going to let theta equal 15 degrees. Therefore, I can use the double angle. I've got cos 2 theta is equal to 1 minus 2 sine squared theta. Well, I know that theta is 15 degrees, so 2 times 15 is 30, so I've got cos 30 degrees is equal to 1 minus 2 sine squared 15 degrees. Therefore, rearranging it, I get 2 sine squared 15 is equal to 1 minus cos 30 degrees. But I know what cos 30 degrees is. It's root 3 over 2. So I've got 2 sine squared 15 is equal to 1 minus root 3 over 2. Right, so I want the same denominator, so I'm going to find the same denominator, so I get 2 sine squared 15 is equal to 2 minus root 3 over 2. If I divide both sides now by 2, I get sine squared 15 is equal to 2 minus root 3 over 4. Therefore, sine 15 is equal to the square root of 2 minus root 3 over 4. Therefore, QED proved.